this is lesson 12.3, geometric sequences and series. Our big question is, how can you find the sum of the terms of a geometric series? So let's look at your frame here. Geometric sequences and series is about understanding what geometric sequences and series are. So sequences and series means the same thing as before. Geometric makes a little bit of a change. So in a geometric series, the ratio of any term divided by the previous term is constant. So we have a term divided by the previous term. So find our R, that's what we have to do if it's not given to us. The constant ratio is called the common ratio, and it's denoted by R. So here's our general rule for it. A sub n equals a sub 1 times R to the n minus 1 power. So write a rule for the sequence and find the nth term. So again, our formula is a sub n equals a sub 1 times R to the n minus 1 power. So our rule for number 1 here, a sub 1 is 12, R is 3, so we can just plug them in. A sub n equals 12 times 3 to the n minus 1 power. Now if we want to find the 9th term, that's a sub 9 equals 12 times 3 to the 9 minus 1 power. So you should pause the video and put this into your calculator. Make sure you can get the right answer. If you put that into your calculator, you should get 78,732. On this problem over here, they give us our a sub 1, that's negative 108, but we have to find our common ratio. So we do a term divided by the previous term, and I'm going to pick the smallest one, so 4 divided by negative 12. If you simplify that, you get negative 1/3. So our rule, a sub n equals a sub 1, which is negative 108, times our rate, which is negative 1/3, to the n minus 1 power. To find our 9th term, that's a sub 9 equals negative 108 times negative 1/3 to the 9 minus 1 power. And again, you should put that in your calculator and simplify it. If you do that, you should find that a sub 9 equals negative 4 over 243. Example 2, write a rule given a term and the constant rate and the common ratio. So one term out of a geometric sequence is a sub 5, and it really should say a sub 5 and give us a value for that, equals 54, we're going to say. And the common ratio, R, equals 3. So we want to find our rule. So a sub n, well, that's 54, equals a sub 1. We don't know that one, so we're going to keep a sub 1 times R, which is 3, to the n minus 1. Well, n is 5, because it says a sub 5 minus 1 power. So this is really 54 equals a sub 1 times 3 to the 4th power. So if we divide both sides by 3 to the 4th, that'll give us a sub 1. So a sub 1 equals 54 divided by 3 to the 4th is 2/3. So we found a sub 1. Now let's write our equation. A sub n equals a sub 1, that's 2/3, times our ratio to the n minus 1 power. Now we want to find a sub 15. So a sub 15 equals 2/3 times 3 to the 15 minus 1 power. And if you simplify that, a sub 15 equals 3,188,646. So again, make sure you can put that in your calculator and get the right answer out. So our next problem, write a rule given 2 terms. So 2 terms of a geometric sequence are a sub 3 is negative 48, and a sub 6 equals 3,072. So first of all, we're going to write the rules that we can. So negative 48 equals, I don't know a sub 1, so I'm going to keep that, times R to the n minus 1. Well, n in this case is 3, so 3 minus 1 is 2. My other one will be 3,072 equals a sub 1, we don't know again, times R to the, and n in this case is 6, so 6 minus 1 is 5. So we now have two equations with two unknowns. This is a system that we need to solve. So the first thing we do is solve for a sub 1. We could really solve for r too, but solving for a sub 1 will be a little bit easier. So we're going to take one equation and solve it for a sub 1. So to get a sub 1 alone, I have to divide by r squared. So a sub 1 equals negative 48 divided by r squared. Second thing we need to do is substitute. And we're going to substitute this into the other equation we haven't used yet. So 3072 equals, instead of a sub 1, I'm going to put negative 48 over r squared in its place, and then times r to the 5th. And if we do a little simplifying here, it's 3072 equals, I've got r squared on the bottom, and really I've got r to the 5th on the top, so you can cancel. 5 minus 2 is 3, so it's r to the 3rd, so negative 48 r to the 3rd. And to solve for that, we're going to divide both sides by negative 48. That will cancel these out and leave me with r to the 3rd. So in order to get rid of that third power, we're going to have to take the cube root. But your calculator isn't going to want to take the cubed root of a negative number, so you'll need to do 3072 divided by positive 48. Take the cube root of that, and you'll get 4, and then we'll put the negative on at the end. So r is negative 4. Now that we've found r, just like any system, we have to plug r back into either of the equations to find a sub 1. So our third step will be to find a sub 1. So we'll use negative 48 equals a sub 1 times r, which is negative 4, to the second power. Negative 4 squared is 16, so to get a sub 1 alone, I'll divide both sides by 16. And a sub 1 equals negative 3. So I now have a sub 1 and r. I can write my general rule. So that's a sub n equals negative 3 times negative 4 to the n minus 1 power. Now that I have finally found my equation, I can find the 15th term. So a sub 15 equals negative 3 times negative 4 to the 15 minus 1 power. And if you put that into your calculator and simplify, which again, you should pause it and try to do that, you'll get 3 million, oops, not 3 million, wrong one there. You'll get negative 805,306,368. Okay, let's look at the other side of our frame. This is finite geometric series, finite versus infinite. The next lesson is infinite geometric series. So finite geometric series means it stops. So here is our formula that we are going to use. Our is about here is about understanding what a finite geometric series is. So our main idea, the formula for the sum of a finite geometric series is right here, where a sub 1 is the first term, r is the constant ratio, and n is the number of terms. Same things that we've used so far. So this first example, we're going to write the separate terms and add them just to see what we get. We want the terms from 1 to 5. So this is 2 times 3 to the, our first term, so 1 minus 1 is 0. 2 times 3 to the 0th power, that's going to give you 2. The next one, we'll do 2 times 3 to the 2 minus 1 is 1. So 2 times 3 is 6. The next one, that's 2 times 3 to the 3 minus 1, which is 2. So 2 times 3 squared is 18. The next, 2 times 3 to the 4 minus 1 is 3. So 2 times 3 to the third is 54. And then if we do 2 times 3 to the 5 minus 1, that's 4. So 2 times 3 to the fourth is 162. And if you go ahead and add these all up, because for a series we need to add all the terms up, you get 242. Now let's do this same one using our formula that's written right above. So s sub n, we want to find s sub 5 because there's 5 terms, equals our a sub 1, which is 2, times 1 minus our rate. Now we can tell our rate by looking over here. Here's our r, here's our a sub 1. We're always going to see those in these problems. So minus our rate, which is 3 to the 5th power, because we've got 5 terms, all divided by 1 minus our rate. So plug this into your calculator and simplify. Make sure you can get the right answer. If you simplify the top, you'll get negative 484. Simplifying the bottom, you get negative 2. So that equals 242. So S sub 5 is 242. We want to evaluate this from I equals 1 through 16 of 4 times 3 to the I minus 1 power. So again, this first number, there's our A sub 1. That 3 is our rate. So let's use our formula. So we want S sub 16, because there's 16 terms here, equals our A sub 1, which is 4, times 1 minus our rate, which is 3. And we're going to raise that to the 16th power, because that's how many terms there are, and divide it by 1 minus our rate. So plug this into your calculator, simplify it. You should get 86,093,440. Example 3 here. Now we want to evaluate from 5 to 15 of 800 times 1/2 to the n minus 1 power. So notice the difference here. Our first term that we're going to use is 5. Our formula, though, gives us the sum from the first term all the way up to the nth term. So what we really have to do here is we have to find S sub 15 and subtract from it S sub 5. I'm sorry, not S sub 5. We want the 5th term. What we don't want is the 1st, 2nd, 3rd, and 4th terms. We don't want those sums. So S sub 4 is what we're going to subtract from this one. So for S sub 15, well, let's fill in our formula. Here's A sub 1, and here's R. So for S sub 15, it's 800 times 1 minus my rate, which is 1/2, to the nth power, which is 15. All of that divided by 1 minus my rate. And if you simplify that, you'll get 1,599.95. S sub 4, well, that's, again, A sub 1 times the quantity, 1 minus our rate, to the nth power, which n is 4, all divided by 1 minus our rate. And again, if you put that into your calculator, we're going to be subtracting these two things. Put that in your calculator, you should get 1,500. So our difference is going to be our sum from 5 to 15. That's 99.95. That is our sum from 5 to 15. Let's look at example 4 here. Find the sum of the first 22 terms in this geometric sequence. Okay, so to find these, we know A sub 1 is right here, it's 4. To find our common ratio, we're going to have to divide. So we do one term divided by its previous term. So 10 divided by 4, if you simplify it, it's 5/2, or 2.5. So we'll just use 2.5 because I know most of you would prefer using a decimal. So let's find S sub 22 using our formula that's right up above on your notes here. So A sub 1 is 4 times the quantity, 1 minus our rate, and we found our rate is 2.5 to the nth power, n is 22. Divide that by 1 minus our rate. So pause the video, plug this into your calculator, make sure you can get the right answer. You should get this. So a huge number, but that is your sum of the first 22 terms. And here's our last example problem. In 1990, the total box office revenue at U.S. movie theaters was about $5.02 billion. So 5 2/2 billion. So that's our A sub 1, our first term. From 1990 to 2003, the total box office revenue increased by 5.9% per year. So that's 0.059 but it increased. So we still have our original amount. So we have to do 1 plus that to find our rate. So our rate equals 1.059. That's what our rate's going to be. That's what we're going to multiply by. So write a rule for the total box office revenue, A sub n, in billions in terms of the year. And really it should say since 1990. So our sum, or our rule for the total box office revenue Okay, so our rule for, and actually I'm giving you a rule for each year, how we find the total for each specific year. We're not adding them all up together. That's A sub n equals our initial amount times our rate to the n minus 1 power. So that's our rule for finding the total for each individual year. So what was the total box office revenue for 2000? Well, that's 10 years since 1990, so A sub 10. So 5.02 times 1.059 raised to the 10 minus 1 power. And if you simplify that, put it in your calculator, you'll find A sub 10 equals 8 and 41/100 billion dollars. So what was the total revenue for the entire period from 1990 to 2003? You have to think about how many years was that? Well, that's 13 years. So we're going to find S sub 13, because I have 13 years, equals A sub 1, I'm out my first year, times 1 minus my rate, to the nth power, well, n is 13, and we're going to divide that by 1 minus our rate. So again, pause the video, plug this into your calculator, and simplify it. Okay, you should have found S sub 13 is 94.18, and that's again in billions of dollars. So this is the end of lesson 12.3. Make sure if there's any questions, you've starred them so that we can talk about them in class tomorrow, and have a great day.